Are you struggling with GCSE probability style questions? In this booklet, we're going to cover mutually exclusive events, which means that two events are independent of each other. And then we're going to also cover conditional probability, which means that this second event is dependent on the first, and that is a higher tier topic. So in this booklet, question 1 says Tom is going to play one game of rugby this week and one game of football. The probability that he's going to win a game of rugby is 0.7 and the probability that he will win a game of football is 0.4. Work out the probability that Tom wins both games. So in this first set here we've got rugby and in the second set we've got football. So we're told in the question that the probability that he'll win a game of rugby is 0.7. So 0.7 will go on this line here. All probabilities are out of 1. So 1 subtract 0.7 is 0.3. So the probability that Tom loses will be 0.3. For football, the probability that he'll win a game of football is 0.4. So if this here is 0.4, then the probability that he will lose is 0.6 because all probabilities have to add to 1. And then again, we've got 0.4 for the probability of winning, and then 0.6. And the question asks us to work out the probability that Tom wins both games. So we're going to draw the path where Tom wins both games. So this is the path where Tom wins a game of rugby and then where Tom wins a game of football. When we go along the branches, we multiply. So the probability that he wins a game of rugby and a game of football, so I remember it like this, where and forms this x, which means times. So we're going to multiply these two probabilities together. So 0.7 multiplied by 0.4, and this is equal to 0.28. So 0.28 is the final answer for the first question. Question 2 says work out the probability that Tom loses both games. So we're going to look at the path where Tom loses both games. So Tom can either win a game of rugby and then lose a game of football, or lose a game of rugby and then win a game of football. So these are the two options here. So option 1 is where we've got the probability of a win and then a loss. So again, we're going to multiply along the branches. So 0.7 multiplied by 0.6, and this is equal to 0.42. And then we've also got option 2, the probability of losing and then winning. So losing is 0.3 multiplied by winning is 0.4, and this is equal to 0.12. Now when we've got multiple options, we then add the probabilities together to get the resultant probability. So we're going to add these two probabilities together. So 2 plus 2 is 4, 4 plus 1 is 5. So our final answer is 0.54. Question 3 says there are red counters and green counters in two different bags, bag A and bag B. There are 6 red counters and 3 green counters in bag A, and there are 4 red counters and 7 green counters in bag B. Lisa takes a counter from each bag at random. Work out the probability that the counters will be different colours. So let's have a look at the probability of a red counter in bag A. So we're told that there are 6 red counters and 3 green counters in bag A. So the probabilities will be out of the total amount of counters. So the total amount of counters is 6 plus 3, which is 9. So both of these probabilities will be out of 9. And there are 6 red counters, so it will be 6 out of 9. And there are 3 green counters, so it will be 3 out of 9. And if we look for bag B, there are 4 red counters and 7 green counters. So 4 plus 7, this gives me 11. So all probabilities will be out of 11. And the probability of a red counter in bag B, well, there are 4 reds, so it will be 4 out of 11. And that means there will be 7 out of 11 for green. So 4 out of 11 for red, and then 7 out of 11 for green. So So work out the probability that the counters will be different colours. So let's draw the paths for the different coloured counters. So we've got red counters and then green counters. And then we've got green counters and then red counters. So like in the question before, we're going to multiply along the branches. So the probability of red and then green is equal to 6 over 9 multiplied by 7 over 11. So 6 times 7 is 42 over 99. And then we've got the probability of green and then red. So 3 out of 9 times 4 out of 11. So this is equal to 12 out of 99. And then we add the probabilities for the different options to get the resultant probability. So this is 42 over 99 plus 12 over 99. So 42 plus 12 gives me 54. So the final answer is 54 over 99. Question 4 says work out the probability that the counters are the same colours. So the path for the same colours is red, red or green, green. So we're going to do the same thing here. The probability of red and then another red is equal to 6 over 9 multiplied by 4 over 11, which is equal to 24 over 99. And then the probability of a green and then another green is equal to 3 over 9 multiplied by 7 over 11, which is equal to 21 over 99. And then we add the two probabilities together to get the resultant. So 24 plus 21 is 45 over 99. So the final answer is 45 over 99. Question 5 says Sarah is going to play a game of chess and connect 4. The probability that she will win a game of chess is 0.6 and the probability that she will win a game of connect 4 is 0.8. Work out the probability that Sarah will win exactly one of these games. So this time we're going to have to draw ourselves a probability tree diagram. So we've got chess, which is the first game, and then we've got connect 4. So in chess you can either win or lose here, and for connect 4 in this case win or lose. So this is our probability tree diagram. Now the probability that you'll win a game of chess is 0.6. All probabilities are out of 1, so the probability of losing is 0.4. Then we have connect 4. The probability of winning a game of connect 4 is 0.8. So that means the probability of losing a game of connect 4 is 0.2. And this is repeated. The question says work out the probability that Sarah will win exactly one of these games. So we're going to draw the path for winning exactly one of these games. So that means we can either win a game of chess and then lose a game of connect 4, or lose a game of chess and then win a game of connect 4. We're going to multiply across the branches. So the probability of a win and then a loss, this is equal to 0.6 times 0.2, which is equal to 0.12. And then we've got the probability of losing and then winning. This is equal to 0.4 times 0.8, which is equal to 0.32. So we've got the two different options. So we're going to add the two probabilities to get the resultant, which gives us 0.44. So this is our final answer. Question 6 says Zach has 2 bags. In the first bag, there are 4 red balls and 9 blue balls. In the second bag, there are 4 red balls and 6 blue balls. Zach takes at random a ball from the first bag, and then he takes a random ball from the second bag. We need to work out the probability that Zach takes 2 blue balls. So we've got bag number 1, and then we've got bag number 2, and the different colours are red and then blue. So this is our probability tree diagram. Now in bag 1 there are 4 reds and 9 blue. So 4 plus 9, that gives us our total, which is equal to 13. So every probability for the first bag is out of 13. we've got 4 reds and then 9 blues. So for bag 2, there are 4 red balls and 6 blue balls. So that means our probabilities are out of 10. Now there are 4 reds, so it's going to be 4 out of 10 and then 6 out of 10. 4 out of 10 and then 6 out of 10. Work out the probability that Zach takes 2 blue balls. So the paths for the blue balls, both of them are blue, is this path here. So this is the probability of a blue and then a blue. This is equal to 9 over 13 multiplied by 6 over 10. So 9 times 6 is equal to 54 over 130. So 54 over 130 is our final answer. Question 7 says Phoebe plays a game where she can win, draw or lose. The probability that Phoebe wins any game is 0.5 and the probability that Phoebe draws any game is 0.2. Phoebe plays 2 games, work out the probability that Phoebe wins exactly 1 game. So we've got 2 things here, the first game and then the second game. So we've got 3 options here now. We've got win, draw or lose, and then we've got win, draw or lose, win, draw or lose, win, draw or lose. Now the question says work out the probability that Phoebe wins exactly 1 game. So the different paths here, we can win and then draw. We can then win and then lose. We can draw and then win, or lose and then win. So there's quite a few probabilities here that we need to calculate. So the probability that she wins any game is 0.5. Draws any game is 0.2. So this gives us 0.7. So 1 minus 0.7 is 0.3. And then we repeat this for the different ones. So 0.5, 0.2, 0.3, 0.5, 0.2, 0.3, and then 0.5, 0.2, and then 0.3. So our different paths are probability of a win and then a draw. And this is equal to 0.5 times 0.2, which is 0.1. Then we've got the probability of a win and then a loss. So 0.5 times 0.3 is 0.15. And then we've got the probability of a draw and then a win. So 0.2 times 0.5 is 0.1. And then we've got the probability of a loss and then a win. So 0.3 times 0.5 is 0.15. So the different options, we then add all of the options up. So this gives us, carry the 1 across. 1, 2, 3, 4, 5. So the final answer is 0.5. This final question says there are 10 counters in a bag. 4 of the counters are red and 6 of the counters are blue. 2 counters are taken at random from the bag without replacement. Work out the probability that 1 counter of each colour is taken. You must show your workings. So all of the questions up to this stage have been mutually exclusive events, where the 2 events that are given in the question are independent of each other. And this is covered in foundation and higher tier, whereas this final question is conditional probability. So this is only covered in the higher tier papers. So what we're going to do first is look at the 2 conditions. So we've got the first pick and the second pick. And the 2 different colour counters is we've got red and then blue. Red and then blue, then red and then blue. So there are 10 counters in a bag. So all of the probabilities for the first pick are going to be out of 10. There are 4 counters that are red and then there are 6 counters that are blue. So if we've already taken 1 counter, say that is red, then that means there'll be 1 less counter. So the total now will be out of 9 because it's without replacement. So you take a counter out of the bag. The first lot had 10 counters, you take 1 out, that means there will be 9 left for the second pick. Now, if you've already taken a red counter out, that means that for the probability for the second pick that a counter will be red is 3 out of 9. So it's deducting 1 from the numerator and the denominator. Now, for the probability of a blue, the blue counters, or the number of blue counters, will stay the same. So this will be 6, and it is over 9, because the first pick was dependent on picking a red, so that doesn't change the outcome or the probability of picking a blue. So this stays as 6, the initial number of blue counters, over a total of 9, because you already took that red out. So if we look for the second section here, we've got, if we've already taken a blue out, then we're going to have the denominator as 9 for both of them. If we've already taken a blue out, there will be now 5 blues left in the bag, but there will be the initial number of reds, which is 4, because the number of reds doesn't depend on whether a blue was taken, because they're different colours. So the question says, work out the probability that one counter of each colour is taken at random. So let's draw these paths. So each colour means red and then blue, or a blue and then a red. So the probability of a red and then a blue is equal to 4 over 10 times 6 over 9. So 4 times 6 is equal to 24, and this is over 90, and then the probability of a blue and then a red, this is equal to 6 over 10 times 4 over 9. So 6 times 4 is 24 over 90. So then we add these two probabilities together to get the resultant. So 24 plus 24 is 48. So the final answer is 48 over 90. So this concludes probability tree diagrams. Remember to drop a like and a follow and subscribe to the channel for more videos like this.